it's a pleasure to be here. Thanks for coming. Perhaps on every Python conference we are attending, we are already used to a certain level of welcoming and this positive community vibe. And here at Plone, it's even more. I don't know, maybe it's multiplied by age of Zope or something, but this is really unique feeling to this conference. So thank you for that. I'm totally enjoying it. So today I'm going to talk about the performance from the subjective point of view, in particular the web performance. And this slide here is not a coincidence that I picked it for the beginning, because confessing, I like that car. That car is small, and it's actually not that powerful. It has 1.6 liter engine. It's like a bottle of Coke, basically. But you take this bottle of Coke and you turbocharge it and you put it in this small and lightweight body, and you add the racing steering system where you feel the road, you add the real exhaust system, the performance one, not just the fake noise. And this feeling of driving is so amazing that even though you know you're not actually going that fast, and every Mercedes would just be much faster immediately than you, but you still enjoy it, and you see that you go exactly 60, let's say, but it feels like 100. And if you're going on Mercedes, you need to push to 200 to have the same feeling. So what I'm trying to say to you, that the speed is totally subjective feeling, at least for most of us here. Maybe to make it more Italian, I have another slide, so maybe you know this beast better. Love it, absolutely. It's a great car. There is no space for a child seat on the back, so it doesn't work for me, but one day I will get it. So speaking about the speed is not absolute, as I say. You know how fast you go, but what matters the most is how fast do you feel when going. And this applies both to the web and to the offline world. So let me ask you a question. How fast could we possibly go if we have no limits? What is the upper limit? It's the speed of light, right? It's the speed of light that limits us. While on the highway we have plenty room of improvement to get there, on the web we are already at the speed of light. I mean the optical fibers. But of course, on the chain from the server to the end user, we have plenty of the points that slow us down. That can be the telco equipment, it can be your Wi-Fi, it can be the software that's parsing the website. But then we forget that after it gets to the monitor, there is one more device that's slowing things down, and that's our brain. Because the brain can do so many funny things with us. The fast can seem slow and the slow can seem fast. And we do not have much of a control over that, except when we really, really focus on the spatial field of science. It's a field of neuroscience about the time perception, which I'm going to cover a bit later. So optimizing, many companies do this mistake. They are optimizing for milliseconds while they totally forget about that last part of equipment or brain, that even if they cut 10 milliseconds here and 20 there and maybe even 100 on top, it might still feel slow. Let me tell you, let me show you better one extreme example. Perhaps everybody in this room, at least one time in their lives, has had some similar experience. It's like the Offal UX ever. Let's say you want to book a trip to Italy, to some fancy place, maybe Capri or something. It's a vacation of your dream, you're ready, you have it in your already pre-booked, and now you want to pay, but then the game begins. You click on that button, pay, and the spinner starts spinning. You wait, you wait, you wait again, and you are redirected to the blank page with some very weird domain. And you wait, and you think, did it work? And then you finally see, we are processing your payment with, of course, the smallest font possible there on top in the upper corner. You see, okay, oh, thanks God. At least it works, so that's all right. And then you wait, and then you wait, and then you doubt, like, does it really work? What should I do? I hit back button, maybe I'll be charged twice. I reload the page, that should work. And then you almost reload it when you see, do not close this tab and do not reload this page. You say, oh, I'm sorry, I'm so sorry, I didn't think of that. No, of course, I'll wait, no problem. And then you wait, and then you wait, and then you're redirected to a home page, let's say, without any notification. Did it work? Did it fail? Did you get charged? So you perhaps have to look on your bank statements or look for emails or call the support. I think everybody has seen it at least once. And that's not just the bad UI, that's absolute trolling of the user. Would speeding up any of these steps do it any better? I doubt that. Even if the whole process would be twice faster, 3 times faster, that's just a bad UX. And it's totally confusing our brain and our perception. So in this case, the absolute numbers do not matter at all. And it's also it's embarrassing, because who is responsible for that thing? It's us, it's developers. Somebody did it, and it feels like there is some secret CMS doing that stuff all over the payment system online. Luckily these days not so much, but I remember it. So what I'm trying to tell you that the speed is not just kilometers per hour, and it's also not milliseconds. It's an experience, it's a feeling that you get while surfing the web. And as one engineer at Google has formulated it, that this feeling of speed that we have is of course in the dependency of the actual performance, meaning the actual seconds. They do matter, obviously, but it's also about the UX, as I say, and don't forget expected performance. Expected means that if you're on the mobile device in the subway, let's say, you understand that you can wait longer, and it's normal. So your expectations are lower, so it does not seem so slow for you as it would if you would be at home on the desktop device. So remembering this simple formula, let's think about what can we improve there. So improving the actual speed is straightforward. I'm not covering it here. There are so many blog posts about that. Google has so many researchers. You can use just simple Google tools that we have, and they have a lot of suggestions. What can you improve to push that numbers beyond limits? Google Lighthouse, for instance. So this is applying a set of techniques. What I'm going to talk about is the perception of speed. And the perception of speed is in fact, it's a very subjective thing, but on another hand, it's also a field of science, a field of neuroscience that's studying all of these temporal paradoxes that we might feel. And the science is based on something that's called the critical flicker fusion of our brain. It's explained in the simple words, it's how fast our eyes are sending updates to our brains. And it's possible to measure that value. So of course, the faster we receive information from the eyes, the more information we get, the more feeling of waiting we have if nothing happens. And it's easy to measure, and this value varies a lot. It varies based on our condition, if we are happy or if we are sad or if we are tired and not. It depends on our age, and it depends even on the sort of species. Like a fly has this brain frequency 7 times faster than a human. So it means that one day lasts 7 times longer for a fly as comparing to the human. And based on this, the scientists have explained many things that we call a paradox. Like, for instance, the holiday paradox is when you go on vacation and things happen so intense that in a couple of days it's already half gone, your vacation, and you think, wow, that was just like that, how fast time goes. But then you go home and you realize, no, actually I have seen so much, it was a pretty big vacation. That's all science, and it's easy to explain if you read. It's like there is a lot of studies about that also on Wikipedia. It's about our brain getting tired of too many impressions that causes this brain frequency to drop. So our time goes faster when we are on vacation, but when we get back home, brain goes back to normal pace, and then when we parse this whole information again, we see, no, that was actually a lot of time. Or another paradox is the age paradox. You know this thing when the kids grow too fast. When we were kids, it took a while, right? We all waited when will I be allowed to buy beer or whatever? But now the kids just grow too fast. And it's also science. So the scientists say that the perception of time differs with the square root of the age, meaning that for a 64-year-old, the time goes 8 times faster than for 1-year-old. So one day would last 8 times faster. That's a lot. So of course, a kid waits when he gets a beer, and the grandmother says, you grow just on my eyes. It happens so fast. So what is a practical use of that for us, for developers? Well, the first learning, of course. No need to optimize for old people, right? The time flies for them anyway. Kidding, no offense. No, we can use that. We can use that. First thing to understand is that this brain frequency depends a lot on either our brain is busy or not. So this brain is certainly not busy, it's idle. So the time goes relatively fast. But then when our brain is in active state, meaning we are focusing on something or we are waiting for something to happen, like when we click on the pay button, obviously brain gets very active, and here we are very critical to every millisecond. So our task, first of all, as web developers, is to focus on the active state, because in passive state, brain does not care. So we need to react to user actions, that when the user is most demanding. And how can we react to that? Well, there are classical patterns. Like there are loading bars, progress bars, and there are spinners. While this worked pretty well, especially in games, like you remember, perhaps everybody, when you play a game, the level has to load. It takes pretty long time, especially in the old days. And when you see the progress bar, it's not just keeping you somehow entertained that the bar is loading and your eyes are following it. It also serves the UX purpose, that it's saying, I'm working, just relax, just wait a bit, because I have a lot of data to be loaded now. So this was a good idea, and it's a good pattern. On the web, I doubt. First of all, it's incomparable how much data has to be loaded for a 3D game versus a website. So a website usually gets, I don't know, if you're talking about some Ajax call, it lasts less than a second. So do you really need a loading bar, a progress bar, or a spinner there? And the very good answer was made here by Polar. They published a little study. So what they wanted to do is they wanted to be as much user-friendly as possible. And in one of their updates in their mobile apps, they added spinner literally on every step where you need to load the new information. So they thought it's user-friendly. When you hit on something and you maybe have bad connection, we show a progress bar or a spinner, and the user is not confused. They just know that you have to wait. And the reviews dropped, like their rating dropped in the App Store. And the feedback was all the same. With the latest update, the app got slower. They didn't change anything on the backend. It was so ridiculous. The speed did not change at all because the process was still the same. It's just the UX that changed. But because every time they reminded the user that you're waiting, and now you're waiting, and now you're waiting again, and now again. So because of that fact, the users got so angry, so confused. Why every action I have to wait? They would not even notice if you just remove these progress bars. And if you have to wait like half second or even 1 second, you can fake it with animations, and that keeps your brain entertained without reminding the user that the user has to wait. So now the common practice on the web is to avoid spinners. If you can, just avoid them. Of course, you have to use a spinner for the UX purpose to say to the users that it's still working. That's fine. If you have a really complicated process that takes time and you have to say that it works, just wait, it's okay. But still consider replacing it with something that keeps the brain entertained while in this active state. Another example is when we just load the page the first time. We do not have many options what to show because the page is empty and the user has to wait for the initial load of the page. And we all have seen this skeleton screen, perhaps everywhere now, Facebook, LinkedIn, everywhere. Hope to see it in Plone. So the trick here is that we use also we use the brains of our client, of the user that's looking on our page, to first find a spot to focus, because according to the study, even though we can receive, like our frequency of brain can parse the image on the monitor within 10 to 15 milliseconds, we need up to 100 milliseconds to find the spot where can we focus. So even though if we show a cat picture, you recognize in 10 milliseconds that's a cat. But if you show a complicated interface, you need 100 milliseconds to look through it and find, oh, is this box what I'm looking for? Where it is? Here it is. So by showing a skeleton screen, even with no information, you already let your user to find a spot to focus. This is how it practically looks. Copied it. This is how it practically looks. On the left, you show skeleton, and you can already see that perhaps news are there in this entries. So you use these seconds to focus, and you are not so confused as on the right example, where everything goes at once, and then you need to spend another 100 milliseconds on top to focus on that screen. An even cooler example is here. When here you have no data from backend yet. If you noticed on the first step, on the first click, you just had the user input. So perhaps I suspect no response from backend at this point. But you already show the interface, so the user can already see the pictures will appear here. And you use, I don't know, 20 to 50 milliseconds of the user time is saved by just showing that in the right order, let's say. What's a bit tricky in this field of studies is how do you measure that? And most of people say it's just about the A/B testing. So you show like in the previous step, the one version on the left, one version on the right, and ask users what was faster. But in fact, there are some technical tools, of course. The simplest is the debugger. You just need to not to look so much about the milliseconds of your asynchronous JavaScripts to be loaded. But there are just two metrics that matter in this case. Is the first meaningful paint, when the user actually sees something, and the time to interactive, when the user gets in active state and the user clicks somewhere, and this is where the user is most demanding. So even if you show already interface that is complete, but it's not clickable, it's not done yet. Because that's when, as I say, that's when the user is waiting for the speed the most. What if we cannot do much there? We have still some tricks to be used to improve the performance of speed without improving the actual speed. First, we have to think about the user. We shouldn't troll the user. My personal favorite is animations. Like, we have SVG support in pretty much every browser, and we have CSS3, and if you show something like that, I'm sure you would not notice that you waited for 10 seconds right now, just looking on that. You would not complain about it, I'm pretty sure about that, because your brain was entertained. You look on something, and 10 seconds is a lot in the web now. Like, if you show a spinner for 10 seconds, that's bad. But if you show an animation, it's somehow good, and it costs you nothing. I mean, in kilobytes, I mean. It's a vector graphics, costs you nothing. Now, can we do even better there? My personal favorite is, I know I'm not the inventor of it, but I just like it because it's games are using this approach a lot. When you put some text on the screen, our eyes automatically reading this text. You know, it's a human perception thing. You put a text, eyes read the text. So when the game is loading, they often show not just the progress bar, but also some tips for the level, or how, or the backstory. But you have to keep it short. So you can have something some even more complicated animation, and if you support it with text, the user is sort of entertained, and you can take even more time of the user. And this is, I think, 20 seconds. That's the trick. So I'm almost done here. This is, as I say, a very subjective topic which cannot be measured, but the key to success in the perceived performance is just to remember that there is a living user every time you develop something. It's not just a machine that measures milliseconds. It's a person with a brain, and this brain will treat the information differently than you think. And if you do not optimize for that, the things can go really wrong at this point. So for this, I owe to, there was a keynote speaker 2 years ago at Plone, Denis, Ukrainian guy, he pointed me here. So this is a documentation of Apple, and we all agree with that Apple is sort of UX pioneers. And they say that the perception of performance is usually as effective as the actual performance. So I saw a lot of great people here in this room who can push the backend to the limit. My message for today is don't forget about the user and treat your users well. Thank you.